Okay, so today we're on 4-7. Identity and inverse matrices. Okay, now let's go through the concept of identity. What is the multiplicative identity?
Times it by 1. Times it by 1.
So the multiplicative identity is what?
1.
1. Anything times 1, you're going to get that thing, whatever it is. Okay? What is the additive identity?
I think like 0.
0. Okay, so an identity means that if we do the operation on the original, what comes out? The original comes out. Okay, that's what the identity is. Now, an inverse, let's look at inverse. What's the inverse of 4? 1 over 4, right? And so the multiplicative inverse of 4 is 1 over 4, and when we multiply them together, what do we get? I heard a 0 and a 1. Which is it?
1. But the 0 goes down.
You shouldn't have to do this on the calculator. 4 over 1, if we multiply a number by its inverse, what do we get? 1. We get the identity. Okay? So there's a correlation between an inverse and an identity. Okay, so what's the inverse of the additive inverse of 5? What's the additive inverse of 5?
Minus 5.
A negative 5, yeah, the opposite. And so 5 minus 5 gives us
0.
0, the identity. Okay? So if we use inverse operation, that should get you back to the identity. Do you understand the relationship between identity and inverse? Okay, you need to understand that for what we're going to do today. Today we're looking at identities and inverse for matrices. Okay, now an application for this we're actually going to do tomorrow, and that is coding, cryptography. We're going to talk about cryptography tomorrow. Okay, so today we're going to skip over that. We're going to go through identity and inverse matrices. Tomorrow we'll come back and look at the cryptography. There's kind of a fun lesson tomorrow, fun homework tomorrow, where we get to decode and come up with a secret message. Okay. Let's have somebody read that. Elan, could you read identity and inverse matrices?
Identity and inverse matrices. Recall that for real numbers, the multiplicative identity is 1. For matrices, the identity matrix is a square matrix. That when multiplied by another matrix equals that same matrix.
Okay, so look at the 2 by 2 identity for matrices. This is the inverse for 2 by 2 matrices. So if we multiply a matrix by this, we're going to get the same matrix that we started with. Does that make sense?
Yeah.
Okay. How about a 3 by 3?
Oh, it'd be like 1.
Do you notice a pattern here?
Yes. Oh, it's just like that.
Could you do a 4 by 4 identity matrix?
Yes.
What would a 4 by 4 identity matrix look like?
1, 0.
Yeah, one's down the diagonal, right? Okay. And I'm sure there's a proof that we can go through to prove that.
No, thank you.
I was going to say you could do it for extra credit if you wanted to, for those
Not true.
that wanted to research that. Okay. So could you read the key concept at the bottom of the page, please, Eva? Identity matrix for multiplication.
The identity matrix for multiplication is I is a square matrix with 1 for every element of the main diagonal, from upper left to lower right, and 0 in all other positions. For any square matrix, A of the same dimension as
For any square matrix A,
For any square matrix of A of the same dimension as I, A times I equals I times A equals A.
okay, so the identity matrix, we start from upper left, go down to lower right, and diagonal is 1, so the main diagonal. And all other positions are 0. Okay? And if we multiply that by matrix that is A, where do they go? A, B, C, D. A, B, C, D. What are we going to get out on the other side?
A, B, C.
A, B, C, D, right. We're going to get the same thing. That's all that's saying. Okay, now let's look at the inverse. If I have a matrix that's matrix A, and I multiply it by its inverse, and this sign up here means inverse. A matrix times its inverse, let's say these are 2 by 2 matrix. Sarah, what am I going to come out with?
Everything negative? The same.
What's the inverse of 4?
1 over 4.
And that equals what?
1.
And 1 is the what?
The inverse.
No, 1/4 is the inverse. What's 1?
The numerator?
Not over here.
I don't know. 1 is the identity?
The 1 is the identity, right? Because 4 times 1 is 4, right? 1 is the identity. So if we multiply a number times its inverse, we got what?
Identity.
So if we multiply a matrix times its inverse, we're going to get what?
Identity.
And what's the identity matrix for 2 by 2?
2 by 2.
Help her out.
1, 0, 0, 1.
See, it even says it right up here. Sarah. It even says 2 by 2 identity. 1, 0, 0, 1. Okay, so a 2 by 2 matrix times its inverse is to the -1. That just means inverse of matrix A. Okay, so let's look at this. If we have, let's put this into application here. And let me put up over here 2 by 2 identity matrix. Identity. Cat is what?
1, 0, 0, 1.
I'm just going to leave that up there as a reminder for Sarah.
It's fine.
Okay, let's look at example 1. It says determine whether each pair of matrices are inverses of each other. Okay, so we've got A, letter A here, well, matrix X, which is, can somebody read that? 2,
2 to -1, 4.
okay, and
Y
Y,
is 1/2, 1/2, -1 and 1/4.
and 1/4, okay. Now remember, when we multiply matrices together, how do we do that?
Isn't it like the top row by column.
Yes, rows by columns. Okay? So x times y.
So 2.
And what do we need to end up with to see
2 by
if,
2. 2 by 2. So you need to add
no, what matrix do we end up with to see if these are identities?
1, 0, 0.
1, 0, 0, 1, the identity.
Yeah.
Okay, so row by column. 2 times 1/2. 2 times -1.
-2. Oh no.
Okay, how about now we do row times the second. Now we do the row times the second one. 2 times 1/2. 2 times 1/4. We'll just keep it in fractions here. Okay? How about the bottom? -1. Now we're going to do this one times the first one. -1 times 1/2.
-1. I mean -1/2.
-1/2. And 4 times -1. -4.
-4. Oh.
-1 times 1/2.
-1/2.
And 4 times 1/4.
1.
What's 1 minus 2?
-1.
-1. And 1 plus 1/2? 1 and 1/2.
Oh, so it's
-1/2 minus 4?
-2.5. Oh, I know, 4.5. -4.5.
-4 and 1/2. And -1/2 plus 1?
No, 1/2.
Thank you.
Oh,
Did we end up with the identity matrix?
No.
No. Those are not inverses. Why did they choose these numbers, do you suppose?
Confuse
To
us.
put in that second matrix.
To make it look like it was actually correct.
Okay, why would it look like it's actually correct? What do we know about 2 and 1/2?
It's the inverse.
Those are inverses of each other, right? And 2 and 1/2 are inverses, -1 and -1 are inverses, 4 and 1/4 are inverses. So, does it follow that we just take the inverse of each element
No.
and we get inverse matrix? No, that's not the way we're going to find out later how to come up with inverse matrices, but that's not the way to do it because this shows that we don't get, okay? So these are not inverse matrices. Let's try a different one. Okay, we have 3, 4, 1, 2. P equals 3, 4, 1, 2. Is that correct?
Yep.
And what's the other one?
Q.
Q.
And it's 1, -2, -1/2, and 3/2.
And what?
3/2.
Okay. So, let's multiply P times Q. Jen's not here. Cat.
3 times 1
Is, okay.
plus 4 times -2, which is
Oh. Rows, columns.
4 times -2.
This isn't -2.
Oh, no, 1/2. In my head it was.
Okay.
So we're -2.
-2. Yes. Okay. Next one.
-6. And 6.
Ooh, this is looking promising, isn't it? Okay. How about next one down here?
1
1
plus
times 1 is 1. Okay.
um, -1. And then -2, -4. No, -2. And then -3. No, +3. My brain's not working out right now.
Okay, so Kat, what's 3 minus 2?
1,
Mine does it on Fridays too. Negative 6 plus 6?
0,
1 minus 1?
0,
And negative 2 plus 3? Hey, did we come out with the identity matrix?
yeah.
Okay. So look at this. Does this look like it should be the inverse of that? You got to be careful. Okay. We got to do the matrix multiplication to figure it out. Okay. So let's go to the bottom there. I want you to check your progress. Number 1, x equals 4, negative 1, 2, negative 2, and y equals 1/3, negative 1, 6, 1/3, and negative 2/3. Wow.
You too.
You have an answer, yes or no? Put your thumb up. You have an answer? When you have an answer, put your pencil down, your thumb up. So we got one with an answer? No? No, just put your thumb up if you have an answer. Okay, so we got 1, 2, 3 with answers, and we're still waiting on one. Let's just go with the answer you got.
I didn't get identity, so yeah.
So you did get an answer though. Okay. Hand up if you say, yes, it is identity. Hand up if you say, no, it's not identity. The yeses are correct, so you can go figure out where you are wrong.
No, I think I multiplied it wrong.
Okay.
Order and stuff.
I think I did.
Arithmetic and signs. Arithmetic and signs.
No, it's not. It's just order like column and row.
Oh, column, you're still working on how to multiply matrices?
Yeah.
Row and column.
Row and column.
Row and column.
There you
Okay,
go.
let's turn over to the next page. Now, you were talking about on the last lesson, is this something tricky where they didn't teach us during the lesson, right?
Yeah.
Okay, I'm going to teach you something tricky during the lesson so you know how to do it for the homework, okay? and that is how to find the inverse. Okay, so if we look up here, we have matrix A, which is A, B, C, D. Okay, now maybe part of the problem is that you're busy writing when I'm talking. You want to work ahead, that's fine, but you got to get it. Okay?
So I don't do work when you're actually writing.
Okay. A, B, C, D. We have and this is a tricky one. The inverse of A, and this is the symbol. This means the inverse of A. The inverse of A. That's how we read that. We haven't gotten to how to do negative exponents yet, have we? Oh, did we do that last year? No.
We don't have it because of chemistry.
Okay. Yeah, so what does a negative exponent do?
It's just times the inverse.
No.
Isn't it just made of S by movement?
Yeah.
So that's
For
for the other
simplification,
direction.
it moves it that way.
Okay. Just for right now, understand that it means the inverse of A. Okay? So, let's look at this now. We have inverse of A is 1 over AD minus CB. A times D minus C times B. Does anybody recognize AD minus CB?
That's multiplication. That's how you.
That's how you continue.
Oh, that's how you find the determinant, right?
The what?
The determinant.
Ah, you get chocolate, yes. That's how you find the determinant. Okay, so AD minus CB is the determinant for a 2 by 2 matrix. So it's 1 over the determinant. And we're going to multiply that by the matrix. Now this is where it gets a little tricky. By the way, if the determinant is 0, what happens?
There are no matrices.
We can't do it.
Yeah, determinant's not be 0, right?
Yeah, because the denominator cannot be 0. So if we come out with a 0 determinant, it does not have an inverse.
Wow.
Okay? If it comes out with a 0 denominator, 0 determinant, we don't have an inverse. You stop right there. Okay? If we can come up with a number there, okay, and it can be either positive or negative, it doesn't matter, as long as we come up with something other than 0. Then we go on to multiply it by the matrix. Now, what did we do here with A and D? No?
We switched.
We switched A and D.
But the other.
You switched A and D, and what did we do with C and B?
Times negative 1.
In the words of immortal Silas Coates, we negatized them. The first year I was here doing Algebra 2, I hadn't ever done matrices before, matrices, yeah. So the class older, Miss Patty was teaching them, and she was gone that week, so I just had them come in and teach my class how to do matrices. And Silas Coates was in that class, so he said, yeah, we switched these and we negatize these. So I like that term, negatize. Okay, so C and B stay put, but we take the opposites of C and B. Okay, and we negatize them. Everybody got that? So now we have a scalar in front, right? And we're going to do what with that when we have those and these numbers? We multiply this times what? Each term. And then we end up with a 2 by 2, right? Okay. Okay, so let's look at an example here. If we have R, which equals -4, -3, and 8 and 6. Our first step is to do what?
Find the determinant.
Find the determinant. Let's do that.
Negative
Okay.
34.
So we have the determinant, and I'm just going to write this down here, equals -24. Keep going. Minus a -24. Anything,
Oh, it's 0, so can't go.
anything subtracted from itself is what?
Zero.
Okay, so what do we do now?
Nothing.
We stop. We say this is no inverse.
Equals inverse.
So R
So R negative 1 power equals.
does not exist.
What was inverse? Identity is 1, but inverse is what?
Inverse is.
No, identity is 1, right?
Yes.
And inverse is,
You mean in multiplication?
yeah, like,
You flip the number over.
that's
in
inverse.
multiplication. In
So-
multiplication.
So if it's an inverse, then your answer should be something like like 1 over 4, 1 over, like negative 1 over 4, like that.
Because we're finding.
While you were doing something else, we did that one and it didn't come out to the inverse. That was our first example. Look back at the first
Right.
example.
So like, when are we doing, we're
So-
not like really,
Right now we are finding out how to do it with matrices. This is how we do it with matrices.
okay,
Okay?
yeah.
Now if you want to know why, you can dig further into that, come up with the proof. Okay, so that one does not have an inverse.
So wait, so,
Because it determined zero.
so
Yes.
when you end up with an identity matrix, then it is an inverse?
Correct.
Yeah, okay, I understand that.
Okay, so now we have P. Let's look at P. Negative 4, no, I'm sorry. 3, 1,
5, 2.
5, 2. Okay, so the first thing we do, Sarah, is what?
3 times 2.
What are you doing?
Multiplying the diagonal. Finding
What?
the determinant.
Finding the determinant, yes. Okay, equals 3 times 2. Keep going.
And then 5 times 1.
Times 5 times 1. Divided by 5 times 1.
Minus.
Minus, there we go. Okay. Which is going to
6
equal what?
minus 5.
6 minus 5, which is? Okay. So now, where does that go in our formula up here?
Under the 1.
Oh, that makes it handy, right?
Yay!
We just have a 1 out front, okay? And what do I do in here?
Times everything in there by 1.
No.
Switch 3 and 2.
Switch 3 and 2.
And
Negatize.
negotiate.
Negatize those ones. And since we're multiplying by 1, anything times 1 is whatever that thing is, that's identity, right?
Wow.
Oh, and I was like confused with the matrix sign and determinant sign again, so I was like, wait, why are we doing a different way?
Yeah, remember, the determinants are straight.
Oh, okay.
Okay, now, that's what we came up with, right? So let me erase this down here. How are we going to check this?
You
See,
can.
we make sure we got the right thing.
We multiply P and P inverse P.
Exactly, and what should we come out with?
0. Wait, sorry, 0, 1. No. 1, 0.
Yes, we should come out with the identity matrix, right? Okay, so that's what we came up with. So let's multiply them together, okay? P times the inverse of P. Sarah, you're still struggling with the multiplication, so let's have you do it, okay?
Okay, so 3 times 2
3 times 2.
minus, what is it, plus? No, yeah, so plus negative 5.
Plus, so can we just say minus 5? Minus 5, okay. Next one.
And then 3.
What's 3 times 2, by the way?
6.
Okay, we'll just do that.
So now it's negative 3 plus 3.
Hey.
There you go.
Okay, down here.
10. So that's negative 10. And then negative 5 plus 6.
Okay, so we end up with,
Wow.
so we know we did it correctly.
So much.
I don't think we'll have enough time to go through the other check your progress there.
Then do we not do some question or?
No, we'll do it. You can do it. I have faith in you.
So there are
I
no
don't
questions.
Guys,
Okay, there is here. So is there any questions in the homework right now that has to do with the example 3?
Example 3? No, we're doing that tomorrow.
Oh,
Yeah, the cryptography we're doing tomorrow.
Oh,
Okay, so the homework is page 213, and we're going to do 9 to 29 odd. Uh-oh.
That's so much. Did you really?
I'm sorry. Hold on.
forgot.
No. We'll just do 19 through 21 odd. Sorry.
19.
9 through 21 odd.
Oh, I feel so excited. Yes, correct.
It's like 3.
That's 7 of them. That's 7 of them. 9 through 21 odd.
And 30 and 31. Yes.
We'll do that tomorrow.
Ooh. What about extra credit?
Oh,
How about that?
Oh yeah, we'll do 30 and 31 as extra credit.
What? So not 34? Or are they all extra credit? Because that's what you wrote on the board.
We're changing.
So what do we do with 21?
So our assignment is 9 to 20.
Okay. Okay, just 30, 31 extra.
30 and 34 are extra credit.
Yay.
30 and 31.
30 and 34. So 9 to 19 odd.
19.
Yep. Oh, I'm sorry, 21. It's 21, right?
Yes.
No, it's 19.
No,
I
let's
told you,
be.
you and me, our brains aren't working today.
Yeah.
Isn't it
Oh,
21?
my brain is
21,
not working
yeah.
either.
21. 9 through 21 odd.
Ah!
And extra credit is 30 and 34.
Oh my